Hi, can everyone see me?
Yes.
All right, so you can see me, you can hear me?
Yes.
Great, okay.
We don't see your
Uh,
screen yet, but
yeah,
that's the next step, I guess.
that's the next step. Yeah, we're taking it step by step here. Okay, let's see. Just a sec. Um, um, all right. Okay, can you guys see my screen now?
Yes, we do.
Okay, great. All right, so my name is Shaul Manevitz. I'm a dev team leader for PrimoV at Exlibris. And I want to talk to you today about something exciting that I've been working on for the past couple of weeks. And that subject is really framework upgrades and customization, or how are we going to make sure your customizations are maintained and are still working once we upgrade to newer versions of AngularJS. So the first thing I want to do is I want to take you back in time. And I want to take you back to 2018, and that was IGeLU. It was in Prague. And here's my time machine going. Okay. So 2018, it was great. We were all in the same room, face to face. But I'm not here to reminisce about that. Um, by the way, I think this guy here is, you might recognize him. um, so back in 2018, I presented something called Primo Studio. And it was great. It created a hype, and I was really excited about it. But there was something that was always bugging me about it, and that was this feature over here, where you would take an existing customization package and you would upload it into Primo Studio and then continue customizing using Primo Studio from that point on. So the question is, why was this feature so problematic at the time? It still is problematic, by the way. And the answer is that behind the scenes, what was going on whenever you uploaded a customization package was I was using a bunch of really complicated regex expressions in order to parse the custom JS file and get all the different components and hooks that you were using and controllers and stuff like that. And turns out this doesn't work very well. So trying to understand code using regular expressions is not really the way to go. And that's what I learned back then. And of course, bugs started coming up, and I started writing more and more complicated regular expressions in order to fix the bugs. But I started getting the feeling that I was not on the right path. And I don't know about you guys, but my experience from writing regular expressions is pretty much summed up in this book. So that was then. Now let's take us back to current times. And the challenge that we were facing today was basically trying to upgrade our AngularJS version. So we were working on it. We had it all ready. We upgraded to 1.7 from 1.6. And then we realized that something was wrong, and we had to roll it all back, and we had to give it up back then. So what was that thing? It was the custom JS. And yeah, another fun thing that happened this year. So so what was wrong was, turns out that when upgrading to version 1.7, we broke a bunch of the custom JS codes that you guys worked on. So what actually happened? Well, AngularJS introduced a breaking change when moving to version 1.7. It was actually introduced from 1.5 to 1.6, but back then it was only deprecated. And when jumping from 1.6 to 1.7, it was already it was already gone. So basically, I'm talking about this pre-assigned bindings enabled flag. And what this caused was whenever someone would reference a binding directly inside the controller function, it would be undefined because Angular, they introduced this $onInit lifecycle hook, and you had to basically reference all the bindings inside this onInit hook, otherwise they would be undefined and you would get a runtime error. So moving on to something that you would find a little bit more familiar. So here's an example of some customization. It's not doing anything very interesting. It's basically just printing out some record ID. But a lot of you guys are using this parent control binding, which gives you access to the parent scope. So for example, in this case, you're using the full view service container after hook. So this parent control is giving you access to the PRM full view service container scope. And so if you wrote something like this, where you would access the parent control directly inside the controller function, after upgrading to 1.7, you would get this fun little error whenever you started up the UI, the Primo UI. And the solution is quite simple in a way. All you had to do was really wrap your code inside this onInit function, and that would fix it. And that's what it also says in the AngularJS documentation. So the problem is now we've got a ton of customization code that customers wrote, and we want to upgrade, but we know it's going to break. So what do we do about it? How do we fix all of the customization package now? So the first option is to let everyone fix it by themselves, and it's not terrible in a way. I mean, the fixing itself is not very complicated, but not everyone is a developer, and some people might get might get confused, or stuff's not going to work, and will get frustrated. So that's the first option. The second option is to automate the process. So I could do what I did back then in Primo Studio, right? I could write all kinds of really complex regular expressions that will try to get the controller function and then introduce this onInit function that will, but as I learned back in Primo Studio, this is almost impossible. So I was trying to find something, and then an answer came to me, because it turns out that there's another option. And the other option is to use JavaScript compilers. So some of these you guys might recognize. So I think that Babel is the most famous one you guys would probably know. It's usually used as a transpiler, meaning if you write, let's say you want to use the newest JavaScript features and language features when you're developing, but on the other hand, you want it to run on Internet Explorer or something like that, and that doesn't support it. So what Babel comes in and does, it takes your code and transforms it so that these new features will be written in a way that older JavaScript engine will be able to understand. And ESLint is usually used during development. It sort of checks your code, and it's usually used for code style or checking stuff like that. And there's a third one, which is not known as well as the other two, but it's called the jscodeshift, and it was developed by guys at Facebook. And actually, that's the one I ended up using, and I'll explain a little bit later why I chose that one. So how do these JavaScript compilers work, and how do they allow us to transform code? So the transformation process works this way. So we start off with some JavaScript source. That's our original code. In this case, just a very simple expression, assignment expression. So what we do is we run this JavaScript file through our JavaScript compiler. And the JavaScript compiler, it parses the JavaScript and turns it into this data structure called an AST, which stands for Abstract Syntax Tree. And this abstract syntax tree is so it's a tree representation of the structure of our code. So you could see in this very simple example, it always starts with this root called the program. And then we have a variable declaration, and this variable declaration is built out of a variable declarator. And then we have, the left side and the right side. So A is the variable we're assigning into, and then we have the right-hand side with an operator. So we're adding 1 plus 2. So that's an AST. And once we have this data structure, so we can traverse it, find all the nodes we want to work on, we want to change, and we can swap things out. So let's say in this simple example, we'll just swap out the node representing the literal 1 to the literal 3. And once we did that, once we edited our AST, then we can come back using our JavaScript compiler, and we can regenerate the JavaScript back from the AST. So what we have now is a transformed JavaScript code. And this is much more powerful than using a regular expression, because the regular expression doesn't take into account the JavaScript structure. It doesn't take into account anything. It's just looking for simple strings. It's a string replacement mechanism. So using the AST, it gives us much more power when we're transforming code. So yeah, ASTs, abstract syntax tree, is basically a tree representation of the structure of our source code. Okay. And I chose to use jscodeshift to write a transformation that would fix a custom JS file. So the reasons I decided to use jscodeshift was mainly this first point, where it would maintain the original code style. So as I said before, Babel is usually used when you push code to production. So you don't really care how that code comes out. You don't really care about line breaks. In fact, you want the code to be compressed as much as you can in order to reduce bundle sizes. But with jscodeshift, it's actually smart in a way where the compiler, it looks at the style of your code before the transformation, and then when you regenerate the code from the AST, it tries to maintain that code style. It provides a nice API for traversing and editing the AST. And also something nice, which I maybe will demonstrate a little bit later, is you can extend that API for more readable transformation code. So for these reasons, I chose to write a transform using jscodeshift. And now I want to move on to an example on this great website called asdexplorer.net. I think it was also developed by the same guys that developed jscodeshift, and I'll show you what it is now. So can you guys see it? Can you guys see my browser?
Yes.
Oh, okay, that's great. Okay. So this is a website called Asd Explorer. And what it allows us to do is just put some kind of source code over here on the left-hand side. And on the right-hand side, it will generate the AST for us. And you can see it here as a tree or as a JSON, whatever is nicer for you to look at. Also, you can see as I travel along the tree, it will actually highlight the code that I'm looking at. So it's very, very useful when you're trying to build these sort of transformations. Not only does it transform our code into this AST, it also allows us to actually test our transform code directly in this website. So I'm just going to set it up. So what I want to use is jscodeshift for a transform. So I'll choose it here. And now you see that I get these 4 windows. So top left-hand corner, I've got my original source code. On the right top, I've got the AST representation. On the bottom left, I have my transform code, and on the bottom right-hand side, I can see my transformed code after it ran through this transformer. So what I'm going to do now is I'm going to put my transformation code and maybe some example of different controllers and components you might see in someone's custom JS file, and we'll see what happens. So just a second. Okay, so that's our custom JS, our original custom JS file over here on the top. And I've got this thing up on GitHub, so I've got the transform code here ready with instructions if you guys want to run it for yourselves. I'll put the link in the, actually I'll do it right now. Let's put the link in the comment section. Yeah. Okay. So I'm just going to copy this transform code. And I'm going to put it on the bottom left-hand corner where our transformation code goes. And immediately you can see that something happened on the bottom right-hand side. So let's take a look. So for example, in this case, you can immediately see the problem with the original code is we're accessing this parent control .icon link directly inside the controller function, and that would fail in version 1.7 of AngularJS. But after the transformation, you can see that we took all this code and we wrapped it in this onInit function. Now, not only that, but we don't want to really take everything and put it in this and wrap it in this onInit function. So things that we might want, we might not want to move into this onInit function is probably this closure where we assign VM this in order to create a closure for this. That's something that we see a lot. And also AngularJS comes with other lifecycle hooks, and they should be created directly inside a controller. So we don't want to have them inside. So we can see that we took the code that we wanted, we wrapped it in the onInit, and we kept the other code outside. Same thing for this component. So you can see we're accessing this control search service, yeah, and we wrapped it in this onInit function. So the transformation code, I'll go over it. It's a little bit technical, but so over here in this section, I'm extending the jscodeshift API, and I'm just adding some function. So this function over here will just return true if the controller already has an onInit lifecycle hook, because in that case, I don't want to add another one. And I'm trusting that the developer knew what he was doing when he added that onInit function. This one finds all the other AngularJS lifecycle hooks. So for example, on destroy, on changes, stuff like that, because these I want to keep outside of my onInit function. And this method over here, it finds this variable closure declaration. So for example, var VM equals this, because these I want to also keep outside of the onInit function. I want them directly under the controller. Okay, and basically this is the first step over here. What's going on here is that I'm telling jscodeshift to transform my original source code into an AST. And this gives me the root of the AST. Now here I'm calling this jscodeshift API in order to find the nodes that I'm interested in. So in this case, I'm looking for controls that are defined as part of a component, because we have well, maybe two types of controllers. We have controllers which are standalone, for example, like this one. And then we have controls which are defined as part of a component. So for example, in this case, we have a component and it has a controller key which holds the controller function. So this part over here finds all the controls that are defined as part of component. Then I'm collecting all the standalone controllers. Now I want to put them all, so here I put them all together because basically the transformation is the same for the same type of, for both types of controllers. And here I'm actually doing the transformation on the nodes that I collected before. So, so first of all, I'm checking if the controller has already an on-init hook. In this case, I don't want to do anything, so I return. Second thing I want to do is find all the closure declarators. So VM equals this. Then I'm finding all of the lifecycle functions because I want to keep them outside as well. Now, this is another powerful thing that jsCodeshift allows us to do. It allows us to create new nodes out of a template. So I'm creating this on-init function that will wrap my existing code, and I'm creating it out of a template. So I don't have to do something. So, I mean, I could do it using these constructors where I would construct a function, and under it, I would construct a body, and I would do all these things, but jsCodeshift allows me to create it out of a string, out of a template, which is really helpful. So once I have this on-init function created, I create a block statement, and I can put this new block statement under my controller function. Now, once I did that, I want to remove the lifecycle functions because now I'm going to have them duplicated. I don't want them inside my on-init function, and I also want to remove all the closure declarators because I have them duplicated as well, and I don't want them inside my on-init function. And after transforming my AST, the last step is to regenerate code, JavaScript code from the transformed AST, which is what's happening over here. So that's the process. Let me go back to the presentation. Okay, so here's a bunch of resources. You guys can take a look at them later. I have the GitHub repository, which holds the transformation code. And this is a nice little website, which allows us to see a graphical representation of an AST. So it's a nice little resource in order to learn about the structures of AST and how different JavaScript codes would look as an AST. Then we have Asd Explorer, which I just showed you, which is a great resource. And jsCodeshift documentation. And if you guys want to look at this quick intro, if you guys want to get into this sort of thing, there's a quick intro on YouTube. So yeah, at this point, I'll take questions. So maybe one thing I want to say before I take questions is what's the next step, really? So I have this transformation code, and the truth is we don't know yet. So we don't know how we're going to roll this out, but obviously this code is on GitHub, and I urge you guys to try it out on your own customization packages and let me know if you find any problem or anything like that, or have any comments. But yeah, you guys can run this transformation and get your code ready for whenever we do decide to move to version 1.7. But I don't know what the rollout plan is yet in terms of Exlibris. Okay, so questions?
Yes, I have one. Well, not a real question, more remark. So this would basically mean that you would be able to hide the way we are creating our modules today, and you would be able to create decorators for our modules instead of people writing the whole Angular module kind of code. And
Yeah.
for the future, if some other framework is used, you could write your transformers for that specific framework.
Yeah, so I think, yeah, that's a great comment, Mehmet. And yeah, I think this new sort of approach opens up a lot of options. So yeah, it's definitely, there's a bunch of options that we could explore using this technology. And by the way, Mehmet, I owe you thanks because you sort of set me up for this talk. A couple of months ago, we had a discussion with the Primo working group about about the future of Angular, and you posed a question back then about why are we still on Angular JS 1.6. So you got me rolling on this sort of talk. So I owe you thanks in that regard.
Okay.
But
there's a question, by the way, for Angular, moving on to Angular 1.7. Is there a certain timeline to go to Angular 1.7?
So so I don't have a timeline yet. I mean, this whole technology is very new for me. I mean, I've been working on it as a side project, and actually I showed it to my product managers about a week or two ago, so it's new for them as well. So no, I don't have a timeline yet for when we are going to upgrade to Angular JS 1.7, but obviously we want to do it in a way which will ensure that all the customization packages are maintained and nothing breaks. So we want to give everyone a chance to get everything in order before we actually do that. And I mean, it's something that we still need to discuss. I mean, maybe we'll try to run the transformation ourselves on all the existing code, but I think that already now anyone who has a customization package can try this thing out and upload it to their sandboxes maybe and check it out, see if everything is in order after running this transformation.
Ulrich has a question. What if someone is using onInit already, but also uses code before onInit to assign variables? What would happen then?
Well, so my transformation, in case there isn't an onInit already, it won't touch the code. It won't touch that specific controller, because I'm assuming if the developer used an onInit, then he knows what he's doing. So anytime my transformation would encounter a controller which already has an onInit defined, it wouldn't do any transformation in that specific controller. About having code that's running already directly under the controller. So from my experience, in most cases, there's no real harm in running code that would run on the controller, moving it to the onInit. So I assume that most of the most code can be moved onto the onInit, but I mean, maybe you guys can find a case where that's not okay, and yeah, and let me know. But obviously, I want everyone to not to just blindly run this transformation and go to production, and this should be checked before.
Yeah, definitely. Okay. There is a follow-up on the previous question, so moving to 1.7.
Oh, okay. Yeah, so
if you are to update the code manually, could we already do so now? or could we add on init to all our components? In other words, since it is already supported in 1.6.
Yeah. So the on-init lifecycle hook is already supported in 1.6. So you guys can go ahead and do the transformations, do the different transformations that you want to do on your code and try it out. And you could even go to production with on-init. Yeah, it will 100% work.
I would guess that that's the preferred path.
Yeah. I mean, if you guys can do it now, then do it now. 100%. Go ahead now and fix up your custom JS files if they need to be fixed up and move it to production. Yeah.
Are there any other questions for Shaul? He'll be back this afternoon.
Yeah, I'll be back a little bit later.
So, okay, thank you, Shaul. It's a very interesting talk.